sun carving project. So the main purpose of this project is for us to apply knowledge of the sun and its position relative to a specific geographic location, and then using that data to inform our design. So we were given a 300 by 300 by 600 volume, and we were supposed to carve that out, or we had creative freedom on how to represent the application of that kind of data in the volume. So the basic premise of the sun path, which is our main sort of tool for understanding the data given to us, is as the Earth rotates around the sun, it's tilted on an axis, and that tilting changes the path of the sun as it travels over a certain point on the Earth. And we were given a certain location, and that was Salicneta in Bulacan. So here are an example of the sun paths that we were tasked to choose three specific times in a day. So I chose 8 a.m., 2 p.m., and 11:42, which is solar noon over Salicneta. It's an arc traversing over a certain point of the Earth. And then throughout that arc, you can determine the direction of the sun, the direction that the sun hits a certain point on the surface of the Earth. We have two sets of data that we have to take into account before we even begin carving out something like this. So the first is altitude and the azimuth. So the altitude is basically the angle with which the sun direction hits the certain point. So as you can see here, if this is the point of interest, this line here is the altitude. So it's the angle with which the sun hits the point. And then the azimuth, this is the angle with which the altitude rotates with respect to north. So that's two different sets of data that we have to take into account when we try to understand the sun path and how it hits the point of reference. So we had to choose the time, and then we had to determine we had to ascertain those two data sets, and we had to take those two data sets into consideration to inform our design. Here, I determined the perpendicular planes that are perpendicular to the sun direction of each time. So these perpendicular planes are like the perfect angle with which to cut the surface of this volume so that it receives the light as best as possible. So using those three planes, we carve out the top of the volume as seen here, planes perpendicular to the sun directions, in order to create surfaces in this prism-like volume that really accommodate the three sun directions well. The interior volumes of the model that I made also coincide with the three angles. So, as you can see here, there are three openings hollowed out into the volume, and they all coincide with the three different times. The first one being 8 a.m., which is this side. The angle at which it has to be, the angle of the sun direction is 30.6 degrees. So if the light shines at approximately 30.6 degrees, this should be the optimal angle with which the opening is cut into the volume. As you can see, it goes straight through. There. Second one is 2 p.m., which is this. And the last one is the main chamber, which is 1142 or solar node. The three holes intersect in the volume, creating a sort of cavernous interior, which is what the goal was. Here you can see how the three planes cut into the volume, creating the prism-like structure on top. So all in all,
before everything, I started by designating a site for my work. So it's located in San Isidro, Pampanga. It's situated in an open area lot, so that so as to maximize the amount of sunlight getting into the structure, as seen here in the diagram. So basically, the main orientation of my structure is that it's this side facing north. Yeah. So it's this side facing north, facing away from the road, and then for the different times of the day and different days of the year that I assigned for my sculpture, I basically decided to use a random date generator because I wanted to keep the random factor as a factor for my carving. I didn't want any bias in the decision-making process as to what time or what day I was supposed to assign my sun directions. So I came up with these two times. So the first one is January 7, it's 11:16 a.m. The second one is August 19, 10:06 a.m. And the third one is September 19, 10:06 a.m. and then August 19, 2:23 p.m. So basically all these hours are randomly generated. And then as for the Sun Altitude and Azimuth, I obtained it by modeling my work digitally in SketchUp. So after having obtained the different times of the day and different days of the year, I decided to carve my structure, also digitally assisted. So we were assigned to start with a cube, or a box rather, that's 300 by 300 by 600 mm. And then after getting the azimuth and the altitude of the sun, I assigned random boxes as well. So one is 100 by 50, 200 by 100, and 100 by 150. So also randomly chosen so that I could keep the structure as random as possible. So I directed these boxes perpendicular to the direction of the sun, so basing it on the azimuth and the altitude. And then after that, I projected it towards the box. And then I intersected the faces in SketchUp, and then I obtained this figure that I was able to model over here. So in turn, creating a structure with 3 different channels. So this is the first one, the second one, and the third one. So each channel with different times of the day, and just to demonstrate or more or less present how it's supposed to look like, is that the sun is supposed to shine in these directions. So because of the size of the holes that I created, unfortunately the shadows that it casted were big, and it occupies the entire space in the interior of the structure, because as you can see here in the section, basically all the projected rectangles from the boxes that I assigned the sun, they all converge towards the center. So with that, it's supposed when the sun hits each specific time and each specific date, it shouldn't cast any shadow, or it should follow the shape of the box that I previously assigned in this part. So after that, basically the assembly process is that after I got these channels or these parts, I enclosed it with the cube. to follow a very basic diagram. So it's here. And because of the randomness, if you look at the plans or the front, left, rear, and right view of the cube, basically there's no symmetry when it comes to the figures or the boxes that the solar carving casted onto it.
What is the importance of light? So in terms of science and the environment, light gives out energy and it is a source of information. And how light travels, it is through straight lines. So its movement is uniform. But through the creation of angles or use of other mediums, light reflects, refracts, or bounces. So this is what creates shadows, depth, voids, and which is really important for architecture. And in terms of the philosophical side of light, it has been engraved in terms of our religion and our beliefs, even in our ancestors, regarding their spirits and where they, when they harvest their crops, or even in the Christian religion, Christ is like equivalent to the light of the world. So in many ways, light is almost everywhere in different field or aspect. And how I designed the solar carving. So basically, under the science, there are two angles that is used, which is basically the azimuth and the altitude. So first, the azimuth is in relation to the angular measurement of the spherical coordinate system with respect of the observer or the object. So the object right here is my carving. And then in terms of the altitude, it is the point of the sun towards the observer or the object right here. So the site, in terms of the location of the solar carving, it is at Salicneta. So it is located at Bulacan. And the time that I chose is around March. So that is because the Philippines is a dry and wet climate. And the time that has the harshest sun rays is around March, April. So I picked that time. And in Bulacan, usually the hottest time is around from 11 to around 3 p.m. So the times that I picked was a little bit earlier than 11 a.m. was 10:30, 11:15, and what was the last? And 1 p.m. So I shall explain the first part. So the first angle that I want to show here over my carving is the 10 a.m. So with respect to the azimuth, it is around 112.5 degrees, and its altitude is 56.60 degrees. So you can see the direction and the drawing of the how I designed and plotted it and with respect of the sun and the use of trigonometry. So right here is this. This is my 10 a.m. And here, this is the process of how I decided to put volume within it. So first, I followed the trigonometry, the angular trigonometry, and then added a planar flat plane, and then I extruded it into a volumetric surface. So the process goes all the same with the other angles. And then next one is the 11:15 a.m. So in 11:15 a.m., it's a little bit higher since the sun is at its peak, one of its peak hours. So with respect to the model, it is quite high. And the azimuth is 139.63 degrees and its altitude is 71.29 degrees. And here is the way I formed this carving out. Same process. And the last one, and the third angle is this one. This is the 1 p.m. or 13 o'clock. So the azimuth at this time is 133.5 degrees and 70.3 degrees altitude. And it's also almost quite as steep as the 11:15, but in a more of the western direction. So generally, after plotting the forms, I have placed them together and created a center where everything intersects. So I wanted to show with my model, without putting any coverings, it's like how they intersect in a central point where where light can be met. And I have cut it in a way where the edges of each point that I've carved is shown. And then remove two faces at the back to show that centering point. So yeah. And this is the faces of how it all came together. And so a little bit of my inspiration of why I chose to use planar and a mix of three-dimensional faces. It's because I love playing with the idea of the void and also planar elements. And with voids, I don't think they're particularly emptiness, but it gives depth when light is shining. So the angular differences represents a moment of time and each shadow in whatever time, given the azimuth, the altitude, it's not replicated the same. It's always different. Every time that a season changes, it is capturing a moment with the model that is frozen in time.
The project beside me right now is my project. As you see, there are different angles. These aren't estimated angles. How do I say this? Rather, all of these angles are based on data. You see, these angles actually came from the first iteration of the model, wherein given the faces perpendicular to the altitude, in order for the face to face the sun directly, you have to calculate for the face perpendicular to the altitude and the azimuth to ensure its direction to the sun. So what we have here are the times I chose, which is, I believe this is 7 o'clock a.m. of the summer solstice. This is 11:57 a.m. of the summer solstice, which is the solar noon of Saligmeta. And this is 4 o'clock p.m. After this, after taking the perpendicular angles, faces towards the sun, the second step is slicing. So the technique I used for this is using softwares I created on digital models in order to properly and accurately overlap the different faces of the different types I chose. And from there, that is where I got my form. So when I was researching for solar carving online, specifically for a building, which the project does not focus on because our task is to make a sculpture. But then it is also important to consider recent findings. In buildings, what's done is they carve through the given solid volume, but a little twist of this project is to create light holes, and part of that carving comes the light holes. As you see, there are 3 simple light holes, 1 per face. The reason behind why I chose to have a simple quadrilateral shape intersecting light holes is because the form itself is already carved in a very angular manner, and I felt that if given a chance to carve the model with light holes, it will somehow cause chaos, and which is not my thing. So, going back to the beginning, sunlight in relation to architecture is a very basic yet essential characteristic of a site, especially when you want to create space that you want to experience. And if you see the spaces inside here, they intersect, and the sunlight does not just stop on the faces itself, but they go inside the structure. There's one on top right here, and they come in different sizes and different lengths. Here are my diagrams with data. So, given that I discussed a while ago the summer solstice of 7 o'clock, 7 o'clock of summer solstice, sorry. Here we have the angles of altitude and the sun azimuth. For summer solstice of 7 o'clock, it's actually 20.9 degrees for the altitude and 70.02 degrees with respect to the north for the azimuth. So given that we are showing 7 o'clock, here it is. So this is the light hold for 7 o'clock. As you see, minimal shadow, but the face receives as much light as it can. Followed by the summer solstice solar noon, which is 11:57. This is the face for that. As you see, it's angled following the altitude, facing perpendicular to the sun. And given that it's a long hole, pretty narrow and long hole, let me try to show it for you. The light touches the end of the hole properly. The walls, given that it's a narrow hole, it does not hold too much light. The sun altitude for the summer solstice solar moon is actually 81.7 degrees, and its azimuth with respect to the north is 0.38 degrees, if you see it in the diagram. Next is summer solstice 4 o'clock AM, or 1600 R, which is this face. The sun altitude for this is 32.43 degrees, and the sun azimuth with respect to the north direction is 18.63 degrees. As you see in the diagram, where there's the height and the length of the sun, given the situation of the site. And this is the light hole for that. Creates minimal shadow from the hole, but the face absorbs and reflects all the light. So as you saw in the diagrams that I was showing while presenting to you the project, what you see under the model drawing is the map of Salikneta farm in relation to the north. So it's situated and faced directly to where Salikneta's north is in order to properly understand the sun path and sun characteristics of the site itself. And that's all for my project. Thank you.
Next. Sir,